All right, guys. So I'm going to do one more video looking at verifying identities. And I'm just going to jump around a little bit on this one to show you a few more examples. Um, any of these examples that we don't go over in the videos, I'll definitely post up on Blackboard for you to look over. And if you do have any questions on them or want me to make a video on any of the other ones, please just let me know and I would be happy to make you a video. Okay, so I'm going to start on this one by looking at example 2E. Okay, so what we have here is tangent of theta minus cotangent of theta all over the quantity tangent squared minus cotangent squared is equal to sine times cosine. So as usual, we want to start by choosing one side of the equation and simplify it down until it matches the other side of the equation. So in this case, I would definitely say the more complicated side is the left-hand side. So that's where I am going to start. Okay. All right, so there's a lot of things that we could try here. So we could definitely start using some identities, splitting things up into sines and cosines. We have some squares in the denominator, so we could try and start plugging in some Pythagorean identities. But I'd like to start more basic than that and just stick with algebra for a minute. Because when I look at this, the first thing that jumps out at me is we have a tangent squared minus a cotangent squared, which is a difference of squares. Now, the reason why I think that might be the way to go on this one, as opposed to trying some of our identities, is because of what we have in the numerator. It's also the tangent minus cotangent, which is going to be one of those factors that comes out of a difference of squares. So it's going to nicely simplify, and then we can start trying to look at some of our identities. So if there's anything that you can simplify with algebra before jumping into the trig, you're going to be better off for it. Okay, so that's what I'm going to do here. I'm going to go ahead and factor out the denominator as tangent minus cotangent times tangent plus cotangent. Okay, and again, like I said, the reason why I'm doing that is because now we have a tangent minus cotangent in both the numerator and the denominator that we can then cancel out. Okay, so this simplifies down to 1 divided by tangent plus cotangent. Okay. All right, so now there's not really anything more that we can do with algebra, so now is the time to start bringing in our trig identities. So nothing's squared anymore, so we can't be using any of our Pythagorean identities. So instead, we're just going to think about our quotient identities. So for that, we can change our tangent to sine over cosine. And we can change our cotangent to cosine over sine. Okay. All right, now from here, I'm going to go ahead and get a common denominator. So I'm going to multiply this first term by sine over sine, and I'm going to multiply this second term by cosine over cosine. Now, if we do that, still have the 1 in the numerator, and we're going to end up with sine squared plus cosine squared over cosine times sine. Okay. Now, the thing that jumps out at me is this guy right here, sine squared plus cosine squared. That's our Pythagorean identity. We know that that is just equal to 1. So lastly, we just need to simplify this. So we have 1 divided by a fraction. And remember, when you're dividing by a fraction, you're really just multiplying by the reciprocal. So if we flip and multiply, this is now just a 1 over cosine times sine. So flip and multiply that, and it would just turn into cosine times sine, which if you look back up, that's exactly what we want. So that's going to be our answer. Okay, so again, on this one, the main thing I want you to take away from this is don't always jump straight to using your identities, but also look for algebraic manipulation that you can use as well. So look for things that might be able to be factored, look for things that you can find a common denominator with. Those different techniques that we've looked at along the way are sometimes a better place to start than necessarily jumping straight into your trig identities. Okay, I'm going to jump down to example 3a. Okay. All right, so looking at example 3a, we have 5 divided by the quantity tangent plus secant equals negative 5 times the quantity tangent minus secant. Okay, so looking at this one, I wouldn't say there's necessarily an obvious choice on where to start in terms of whether the left or the right looks more complicated. They're fairly equal this time. You could maybe say the left is a little bit more complicated simply because it has a fraction. So I'll go ahead and start there, but really you could make it work on this one starting on either side. But I'll choose the left. Okay. All right, so again, looking at this one, we have some different options, okay? We could maybe think about jumping straight to our trig identities and plugging in things for the tangent and secant, or again, we could start by trying an algebraic technique. Now, something we haven't looked at in a little while is something that I introduced to you in the video on using the fundamental identities just to simplify trig expressions. And that's the idea of multiplying by a conjugate, okay? So remember, whenever you have some sort of sum or difference in the denominator, typically it's going to be like a trig function plus 1 or a trig function minus 1, but it can occasionally be a sum or difference of 2 trig functions as well. It's sometimes helpful to multiply by a conjugate to try and simplify. Okay, now the reason why I think this might be a helpful technique in this particular situation is because the conjugate of tangent plus secant is tangent minus secant, which is exactly the factor that we want to get to on the right-hand side. So it's because I see that conjugate on the right-hand side that I think it might be a useful technique to multiply by the conjugate in this case, okay? Now, there are certainly other ways that you can solve this problem, and I'm not even necessarily saying that this is the best way, it's just a way, okay? That's going to be something that you'll notice on a lot of these trig identities is there are lots of different paths that you can take that are all going to get you to the same final answer. It's just some might be longer than others, but there are a lot of different ways that you can go. Okay, so just because you might not necessarily choose the same path as me doesn't mean you're doing it wrong, it just means you're doing it differently. As long as you're using correct mathematical techniques, it's okay if you do it a little bit differently, okay? All right, so we are gonna go ahead and multiply this by our conjugate, tangent minus secant. And just remember, when you're multiplying by something, you have to multiply by 1, meaning you're multiplying by the same term in the numerator and the denominator. Okay, so now we have 5 times the quantity tangent minus secant in the numerator. Okay, this is good, right? Because like I said, that's generally where we're trying to get to. So let's go ahead on this one and let's FOIL out that denominator. So tangent times tangent, we would get a tangent squared. Okay. And then just like every time we multiply by a conjugate, our middle terms are going to cancel out because we have a negative tangent times secant and a positive tangent times secant. So those middle terms cancel. That's going to happen every single time you multiply by a conjugate. And then we would get a negative secant squared. Okay. All right, now this denominator right here should look familiar to you. Tangent squared minus secant squared. So if you go back to our Pythagorean identities, you should hopefully remember that 1 plus tangent squared is equal to secant squared. So if we rearrange this, we want a tangent squared minus a secant squared. So we would subtract the secant squared over to the left, subtract the 1 over to the right, and we would come up with tangent squared minus secant squared is equal to -1. So we can go ahead and substitute that into the denominator here. So that denominator just turns into a -1. Okay. But when we divide by a -1, basically we can just multiply the numerator through by a -1. So this would just be 5 times the quantity tangent of theta minus secant of theta. And if you look back, that is exactly what we're trying to get to. That is our right-hand side. So we're done. Okay. All right, let me do one more example with you. Okay, I'm going to go ahead and look at part E here of example 3. So 1 minus sine of theta over 1 plus sine of theta is equal to secant of theta minus tangent of theta quantity squared. Okay. Okay. All right, guys, so once again, there are definitely different ways to approach this problem. Even from the get-go, looking at it, it's kind of hard to choose whether we want to start on the left-hand side or whether we want to start on the right-hand side, because both sides are about equal in their difficulty level, I suppose. On the left-hand side, we have the fraction, but on the right-hand side, we have the quantity squared. So there isn't necessarily an obvious choice on this one. So I would say just choose a side to start with and run with it, okay? I think maybe the right-hand side looks a little bit more complicated to me on this one. So that's where I'm gonna go ahead and start. But if you wanna give yourself a challenge, go ahead and start on the left-hand side and see where you get, okay? It's definitely a valid choice to start on the left-hand side. It's going to be a slightly different path to get there, but you should be able to still prove this identity. Okay, so looking at this right-hand side, we definitely have some options, okay? But the thing that I want to try to do here is I'm actually going to start with my trig identities on this one. And I'm just going to use my reciprocal and my quotient identities to change my secants and tangents into sines and cosines. Okay, I just want to try and simplify this a little bit in terms of the trig functions if I can to start with. So secant I know is 1 over cosine, and tangent I know is sine over cosine. Okay. Now, nicely enough, we already have a common denominator in here. So this is going to be 1 minus sine of theta over cosine of theta. Okay. So this is good. Okay. We now have that 1 minus sine of theta in the numerator that we want to have for our final answer. Okay. All right, now this is all still quantity squared. So I'm going to go ahead and I'm just going to write this as 1 minus sine of theta quantity squared divided by cosine squared of theta. So kind of distribute that square to both the numerator and the denominator. Okay. Now looking toward where we're trying to get to, we don't want any kind of cosine in the denominator. So I'm going to use my Pythagorean identity in order to swap out that cosine squared for a sine squared. So once again, remembering our Pythagorean identity, sine squared plus cosine squared is equal to 1. We know that cosine squared is equal to 1 minus sine squared. All right, so making that substitution, you'll have a 1 minus sine squared in the denominator. Okay. Now, like we've talked about before, 1 minus sine squared is now a difference of squares. So I'm going to go ahead and factor that. It's going to be a 1 minus sine times 1 plus sine. Okay. Now, the reason that I thought to factor this is because I knew that when I factored my difference of squares, I would get that 1 minus sign, which would cancel with one of the 1 minus signs in the numerator. So I was sort of thinking ahead to, well, what if I did factor it? Would it help me simplify in the next step? So you kind of want to be trying to think a step or two ahead when you're solving these problems, when you're proving these identities, to kind of think about, well, if I do this, will it help? Okay. And also, don't be afraid to take a step and then, go a few more steps and say, hey, this seems to be leading me down a rabbit hole. I don't think I'm progressing. And just go backwards, cross off a few lines, erase a few lines. It's not the end of the world, okay? But making those mistakes might help you realize what a better option might have been. Okay, so in this case, though, factoring that did seem to help us because we can now cancel out one of those 1 minus sign factors, and we are left with 1 minus sign divided by 1 plus sign, which if we look back up at our original problem, that is exactly our left-hand side, which means we're done. Okay, guys, so I'm going to go ahead and end this video here. So like I said, any of the problems that I didn't work out in the videos, I will post the solutions to up on Blackboard. And if you do want to see any of the rest of these worked out, just let me know and I would gladly make a video on some of the other ones. Okay, so keep practicing. I would definitely recommend that you try the rest of these proofs on your own. And then if you get stumped, then definitely compare to what I have posted and try as many of the homework problems as you can. The more practice you get on these, the more comfortable you're going to get with them. Okay. Nobody's a natural at these right off the bat. Okay. They're not something that's going to be super quick. They just take a lot of practice, and that's what's going to help you start to recognize some of these patterns and understand these identities a little bit better. Okay. All right, guys, so keep working. And in the rest of this unit, we're just going to keep going with some new identities that we're going to add to our list of fundamental identities.